all of the public data has already been consumed. It's already been gobbled up. So the way to get additional improvements is around proprietary data. Companies are very reluctant to use that with good reason, because once it leaks, it's gone forever. It gets consumed into somebody else's model, and there goes your strategic advantage, your competitive advantage. Hi, welcome to AI Confidential, a show about AI and how to benefit from it responsibly. I'm Aaron Fulkerson, the CEO of Opaque.
And I'm Mark Hinkle, the founder of the Artificially Intelligent Enterprise Network. All right, today we are doing something a little different. Instead of interviewing a tech leader about AI, we're going to break down the debate that's going on in the AI world right now. Are LLMs dead or not?
We should have had Ruve on this, because our friend Ruben Cohen wrote about this in a LinkedIn post, and he writes that the tech world's lost its mind and LLMs plateaued more than a year ago and everything else has been incremental at best, which, yeah, I mean, there's some truth to. And he points out that the SWE bench verified numbers point to this as well. And there's been a lot of discussion about this around the launch of ChatGPT 5. And obviously, I don't think they're dead, but I think what we've seen illustrated with ChatGPT 5 is that we're reaching the upper bounds of the possibilities with LLMs. When we see these models drop, we're not seeing these huge step function improvements in quality.
Yeah, I agree. When we first saw ChatGPT, and I guess that was GPT-3, most of the world had no comparison. Now we see new ones coming out from Claude, Gemini, GPT-5 just came out, and compared to 3 years ago, it's amazing tech. But where it is 6 months ago is like, it's just a meh incremental upgrade. And I think that's what everyone's saying is we had this huge, exponential leap over and over again, and now it's just 5-10% better. I guess, it's hard to say for sure how much better each version was, but they don't seem to be the huge upgrades that they had been in the past.
Yeah, and I think that there's something happening around AI right now, which we're familiar with in technology, the hype cycle. And we are tipping over the peak of hype and sliding into the trough of disillusionment. And it's a common framing of how a particular technology will come out. It'll capture the attention of a community, in this case, the global community with AI. And people's expectations will continue to grow. And then there's a point that it tips into a downward trend of criticism. And that's exactly what we're seeing, because we're not just seeing people expressing their disappointment with ChatGPT 5, we're seeing it across a variety of different spaces with an AI that we're going to get into as well.
This is a technological phenomenon that we see all the time, is that we come up with a new tech, we maximize its potential, and we keep doubling down, and you get to the point of diminishing returns. I think a good example could be like CPUs and GPUs, right? So CPUs, when it comes to artificial intelligence and neural networks, aren't very efficient, but we're pushing it. And then you had NVIDIA come along with CUDA and basically turned graphics cards into supercomputers. And initially you saw 1600x improvement in performance on the data crunching. And that's why everybody wants GPUs right now. But there's other technologies and techniques that we might want to look at to get to the next level, just like transformers and neural networks that actually work, like AlexNet from, I think that was Jeff Hinton, sort of started the whole ball rolling again after an AI winter, wherein they You know, we're having a cold, cloudy weekend in San Francisco right now with the LLM controversy, but that probably too will clear with some additional updates. But what are you thinking?
Well, there's a bunch to unpack here. One of the things that I've observed, you see this a lot online, and I've actually talked to friends about this, where they were very frustrated by the launch that OpenAI rolled out with ChatGPT 5 because they'd become so attached with the interactions they were having with 4.0. And you'll see a lot of people who have written articles where they do analysis across multiple vectors for specific capabilities like writing or analysis. And I've read a few of these, and generally people are claiming that they feel Chat 4.0 is superior to Chat GPT 5. I don't know if that's true. Like I looked at the comparisons. My experience is I think ChatGPT 5 is incrementally better than 4.0, but it's worth noting that what I think we're experiencing is people are developing a personal affinity for the person, the actual personality of the way that the model's communicating with them. You even see people writing about this. Like I lost a friend, which is I don't do this kind of personally. I don't anthropomorphize the models. I do have a bad habit of like being really polite because that's just how I communicate, which that's another funny factor that Sam Altman talked about like a couple months ago, where the hundreds of millions or tens of millions of dollars that saying please and thank you to the models cost this company. But I don't feel like a sense of personal connection, like an emotional connection with the way that these things communicate with me. And people do.
Everybody likes a certain tool for a certain job. And so if you're a carpenter and you were carving wood, you might like a different kind of chisel for different things. I think that's what was happening with, even me for GPT. I would normally start with GPT 4.0. And then when I needed quick, good reasoning, I would do the O3 and the O3 mini. And then eventually I think it was O4 high. And it's so funny because I knew exactly which one, and I'm switching all the time based on my task. Now, what they've done essentially is they're using an LLM router to basically decide which model and which expert, if it's a mixture of experts, is best for your use case. And obviously, they didn't have the training data on how we used it. And also, you mentioned something really that I always think about, and I'm so jaded, but Sam Altman said, and I think the number was $50 million a year it's costing them to handle please and thank yous in the Chat GPT. Well, I think what's happening now is they're probably the LLM router portion of Chat GPT is learning from us, and I'm a little cynical in the fact that if you're learning, is there also some calculus in there to say, hey, let's optimize for power consumption and processor consumption and everything else, because every single one of our queries today is essentially they're operating at a loss. So, until they get to the point where compute and processing is cheaper, they're losing money on every query. So what do you think of that?
The point you just made about how OpenAI is using our interaction data
Mm-hmm.
with ChatGPT to optimize like which model it's using
Mm-hmm.
is super interesting and important to note. I had a conversation with a financial services company that does wealth and asset management, and they were sharing with me that they believe that OpenAI isn't using their proprietary data that they're using in OpenAI to train their actual models. But what they are absolutely certain of is across their different financial analysts, even when they're creating like an evergreen account, over the last year, they've observed that the ways and means in which they're interacting with the data, like the actual user experience, the behaviors in which they're interrogating the data, the questions they're asking, how they're doing that, is clearly training and creating better outcomes.
Mm-hmm.
So why is this significant? Like, oh, that's great. You might say that's wonderful because then it's actually helping me to learn from to get the benefit of other people's interactions with ChatGPT models to deliver me better outcomes. Well, if your business is financial services and you're in the business of having the best financial analysts who are taking data and interrogating data, and the system is learning their specific ways and means, it's a regression to the mean. It's creating everybody's going to have the same ability because it's learning how to get to a specific outcome that's desirable through the interactions with the data. Now, that's the intellectual property of that financial services firm. So it's a huge issue for them because they're like, wait a second, we're like training through the metadata that's created as part of our interactions with the system, our secret sauce, our financial analyst differentiation. So I think you're right that the way in which they're using it kind of like an LLM router to select which models and then intuiting based off of a broad corpus of people's interactions with the system is improving the outcomes. But of course, in the enterprise context, that's a really significant problem because you're leaking your secret sauce.
Yeah, 100%. So when it comes to that secret sauce, I think that we will more than definitely see more and more small language models, and I hate language models because I think we're going to see small models that are very, very specific. And the problem will be you'll either come together as an industry and say, we're going to agree on owning this, like a trade organization. So let's just say, your example was finance, that the JP Morgans and the Bank of Americas and the Goldman Sachses of the world join a trade organization, not unlike with Linux, and say, we're going to have a foundational model that we will train and we will all use, but those best practices in the industry we all benefit from, and then our data will be the addition. And that's a little controversial because we don't know how close you draw the line between process knowledge and specific financial data and maybe even some other kind of data on special projects within a company. But I think you're almost going to have to see a level of specificity beyond the foundational models, because otherwise they will just own us all.
I totally grok what you're saying. I'm going to tie it back to the original concept. There's the data used to train the models.
Mm-hmm.
There's the data that people are using as context, like the proprietary data in conjunction with the models. And then there's this metadata that's part of the interaction stream with these systems. And these systems aren't a single model. They're a collection of models that are interoperating with each other and being routed. So the example I gave about a financial analyst whose specific processes in which they leverage the model is generating this metadata, which is actually their secret sauce. Like, think about it from a financial analyst standpoint. Mostly they're operating on publicly available data, but they have a specific process that's their intellectual property that gives a differentiation in market for why their customers are going to work with them, because they get better returns because they have a specific process to interrogate that data. Well, if that metadata is being collected and used to benefit everybody who interacts with the system, you're actually eroding your differentiating value by making it, as is commonly known, a regression to the mean, meaning that AI regresses to the average. So everybody has basically the same output. Well, that means that your secret sauce is now part of that soup that's being served to everybody.
Yeah. And I think the architectural pattern that enterprises will have will be not unlike what Altman is doing with OpenAI. So I think you'll have a LLM router. So we had, the Light LLM is a popular one, or we had Marco Palladino on earlier this season from Kong, where based on the context of the query, it routes to an LLM. So I think you'll have almost the equivalent. You'll have a general purpose safety. I want to learn about a general concept in the world, and I'll go to ChatGPT or one of the OpenAI models, Gemini, maybe Facebook someday, whoever, or Meta. But then you'll have other specific models. So you will have the financial models, and this is the part where I'm not sure how it's going to play out. So you're basically saying that the process could be my secret sauce for one of the large financial vendors. I'm always going under the um, assumption for AI is eventually we're all pretty much going to have access to the top AI. It'll be like electricity and internet, is it'll commoditize. So I'm trying to figure out what is that part of the model or part of the AI layer that is your specific competitive advantage. And is it all of your data and all of your processes? Or is it some of your processes and some of your data? And that's the question that I think remains unanswered to me.
So let's go back to the original concept of the innovation from LLM seems to be moving from a step function to a more incremental curve. That doesn't mean that we're going to see a slowdown in the AI landscape, and the reason is really twofold. One, the data, as we've already explained, that's used in AI models has all of the public data has already been consumed. It's already been gobbled up. So the way to get additional improvements is around proprietary data. And I'm using that term broadly because that could be your actual proprietary data related to your customers, your processes, etc. It could also be metadata with how you interact with these systems as a human, like the processes that you execute, the workflows that you execute. So I'm just going to say proprietary data. Companies are very reluctant to use that with good reason, because once it leaks, it's gone forever. It gets consumed into somebody else's model, and there goes your strategic advantage, your competitive advantage. Totally separately, there's the underlying architecture, right? So there's the architecture that's currently transformer based, and there's a bunch of innovation that can happen there. All right, so let's address the whole data question, which is one of the vectors for significant improvement before we get into the architecture. Imagine AI models like ChatGPT. These are like culinary students that are trying to become master chefs. And in their journey, they're consuming all of the publicly available cookbooks. Well, now this particular culinary student has consumed all of the cookbooks there are on the planet, all of the publicly available ones. In order for them to get better, there's a whole wealth of data that's sitting around, or information, culinary information sitting around. That's, for example, secret family recipes that are passed down for generations. The actual techniques for executing the steps within the cookbooks. For those of you who've cooked, you totally can, you've seen this where you can follow a recipe and somebody who's more experienced as a chef can follow exactly the same recipe and it tastes orders of magnitude better than what you cooked. It just is way better and you don't know why. So there's specific techniques that are, maybe coveted and kept private by professional kitchens. And then there's like trade secrets around selecting your ingredients. How do you select your ingredients that go into it? So if you think about the data that's used within these models, it's a lot like culinary students that are trying to become master chefs, and they've already exhausted all of that public data. But there are just troves and troves and troves of super valuable information that will help them become a master chef, which they have not been able to tap into. And the reason why is companies have tons of private data, emails, documents, customer interactions, metadata about workflows that could make AI much better and smarter, but it's locked away behind corporate walls. So that's one vector that's super critical to understand. Now, the second one around the architecture is, first, you can use the stupid model with the publicly trained data, right? Or you can use your data in an unsafe way with these models, because it would be unwise for you to use this data without having some kind of verifiable guarantees around the data privacy so that you can retain ownership or sovereignty. Because once you leak it, it's gone forever. It'll be a regression of the means, as we've discussed, and you'll just be the average of everybody else and all of your differentiation goes away. But here's the point. Either way, let's say you do want to use this data with the current architectures. Well, transformer-based architectures are what we call quadratic complexity. I'll use another analogy with this. What that means is you'll hear about like blowing out the context window. Um, the way that these work is that anytime you want to call upon something, you have to load everything into memory. So I'll use another analogy. Let's say that you're a college student studying math, and somebody asks you what's 2 plus 2. In order for you to answer that question using the current architecture, you would have to load your entire math curriculum into memory. You would have to understand everything from basic arithmetic all the way into theoretical calculus and combinatorics. And you'd have to load this all into memory to answer a simple question like, what is 2 plus 2? That is what we mean by quadratic complexity. Now, there's new approaches that are what's called linear. So there's a variety of these. We'll touch on them. What linear means is that you don't have to load every piece of information on the planet about math into memory in order for you to answer a very simple arithmetic question. You can just immediately go to the folder around addition and answer the question very quickly. Now, the significance of this is it's not just a performance improvement in terms of speed. It's an improvement in how deeply you can do reasoning, because you can string together answers much more quickly, meaning you can process much larger data sets. So that means that, hey, listen, if I'm a chef, I don't have to load all of every single public cookbook, every single trade secret within a corporate kitchen, or every single recipe from everybody's grandmother into memory just to figure out how to do coq au vin. Instead, I could just load coq au vin and I can execute on coq au vin, or the steps within coq au vin.
I think what you're coming up with then is, if we divide that data between, let's just call it common knowledge versus experiential data. So that's the 30 years you put in to become a master chef. That's the 10,000 hours that took the Beatles to become the Beatles. Is that part, that stuff that you can only come up with is from experience, is what people want to hold back. But if they hold that back, will that limit the model? The second thing is, I think what people want is almost like in the Matrix, where people like, I can just download all of that stuff and immediately become a kung fu master in 60 seconds. The third part of that is quadratic versus linear. You know, when we first got GPUs, we got such a big performance hit that what they were basically doing, and I think this is Ilya Sutskever, the co-founder of OpenAI, was talking about when he did it, is when we all of a sudden we had so much power, instead of giving you the directions to the nearest Starbucks, we gave you the directions to all the Starbucks in the world and let you pick that. But now that we're pushing the limits, that efficiency of giving you the path to every Starbucks is sort of the quadratic approach. And the linear approach is just give me that directions to the closest Starbucks. And that might scale better because it's not as data and compute intensive. Is that what you're saying?
For sure. And you've seen like Ruve talks about this. A lot of people are talking about it. They're kind of mimicking these new architectures from like state space and recurrent families by breaking up the problems into a subset of agents. So that's where you have like these multi-agent systems. So they're kind of hacking around the constraint of, well, I can't load the entire map of every Starbucks on the planet just to figure out a Starbucks that's near me. Instead, I just want to, right. So what they'll do is they'll break it up into subsystems or sub agents as part of a multi-agent system to kind of hack around this problem, where other architectures for AI models, whether it's like neurosymbolic or state space and recurrent families, they're just taking entirely different approaches. The point I'm making here is two primary vectors we're going to continue to see innovation. The real low-hanging fruit is unlocking your proprietary data. And obviously, opaque being confidential AI, we do this all the time, where the specific LLM switchboard you're talking about, one of the customers that we have that's public is ServiceNow, and we run their confidential one LLM switchboard in an opaque environment that allows them to provide guarantees so that when they're pulling in data from across all these disparate systems which span trust boundaries, there's guarantees around data policy compliance and proof that it's not leaking information, right? So that's one low-hanging fruit for innovation to drive acceleration in value from AI models. The other is really at the architectural level, and we leave that up to the frontier model labs, and they all have interesting work going on to provide new engines for these AI models. But in order for us to achieve real ROI, like return on investment inside the enterprise, it's really the only way to create like a defensible moat or any kind of competitive advantage is around that low hanging fruit of your enterprise data.
And I think one of the reasons that we're having this discussion is also that MIT report that came out that said 95% of generative AI pilots at companies are failing, which I believe 100%, because it's not unlike any new technology trend. Everybody invests on that front end of the curve as it starts to fill up the headlines. We're in that hype cycle or that trough of disillusionment right now before we see the big
it's
rise.
going to get worse. We're just cresting the peak, and over the next, I'd say 6 months, we're going to drop down into the deep trough of disillusionment. I want to go back to that MIT research that was published. They did a analysis of enterprise AI deployments, generative AI. 95% of them are delivering zero measurable return on investment. And that wasn't a typo or a misstatement. It was 95% are delivering zero ROI. They further went into companies that buy AI tools from vendors succeed 67% of the time more than those who are trying to build their own. And the biggest return on investment seems to be back office, whereas the preponderance of investment with AI has been front office, like sales and marketing. So there's a lot here that we should dig into. One of the important points is like there's been $30 to $40 billion invested in generative AI in the enterprise. Only 5% of pilot programs achieve meaningful business impact. The bottom line here is they're using off-the-shelf models, or they're trying to train their own models. When they do this, the key thing is that I keep coming back to is in this age of AI, where AI is the new platform, it's your proprietary data. It's not just that it's valuable, it's your only moat. Once you leak it, it's game over. And in reality, in these enterprises, they're not using their proprietary data. They're not integrating into their workflows. And this came out of the research too, was they talked about like integration. So another key point is that 90% of workers, I hope it's 90%, are using some kind of AI tool. They're using ChatGPT or Claude, which if you aren't using that, like I probably don't want to work with you. So I'm like setting the table with all of the facts from the article so we can discuss more clearly about them. As you said, this doesn't surprise me.
Yeah, no, it doesn't surprise me at all. I'm guessing that the large corpus of data is from existing older companies, probably larger companies, because when you look at companies like Cursor and Windsurf and these companies that are growing at tens of millions of dollars of revenue month over month, you have to say, well, those companies, their pilots are all like killing it. But if you have an existing workflow and existing unstructured data, and as we previously discussed, you're not sharing the data that you do have, you're probably not getting the advantage, and you don't know how to get forward without, is it a compute problem? Is it a data problem? Is it both? Is it a architecture problem? As we've covered all three of those things, you're just probably stuck in trying to use the wrong tool or not use the tool because you're scared you'll cut off a finger.
So it was very specifically focused on enterprises that they surveyed. So they're big companies. So you're faced with like three options. Stay stupid. I'm just going to use AI generically. And that was another call out in the paper, was that the people that they spoke with were using it for sales and marketing, which you receive those cold outreach emails and
Yep.
LinkedIn messages. They're really bad. And it's just
Mhm.
ChatGPT generated or some other model generated outreach. So that I would call that stay stupid. Option two, be crazy, go unsafe, and just roll your data into these foundation models without any kind of verifiable guarantees. Well, they're not doing that. And I speak with enterprises every day. I'm not alone. There's all kinds of third-party research. Less than 11% of CIOs in the enterprises have adopted generative AI. When they do so, they're not integrating their data. The number one factor for getting ROI from generative AI and agents consistently comes up as data security, data privacy is the number one thing blocking them from going into production. So that really leaves the third door, which is you got to go confidential. There's no other way for you to provide verifiable guarantees around your data being kept private unless you're doing it using confidential AI. And there's a bunch of people. I mean, I had a call with the Azure team yesterday, and all of their critical AI and internal processes are converting to confidential. So it's not just them, it's Meta, it's Apple, it's Google. They're all rolling out confidential guarantees because the nature of these non-deterministic systems require you to do that in order for you to get to scale. You have to have a trust layer that's verifiable.
What you're hitting on is actually a technology that we've had for a while now, but I'm going to back it up because of what I do. I train people on how to adopt AI for their companies. And I think when we talk about these pilots failing, they don't know about confidential compute as a way and trusted execution environments that already exist and is accessible in their hardware. But that leads to the bigger question. I trained 100 people that were part of Women in STEM here in Triangle recently. I'm sure that over 50% of them had PhDs and the majority of them had masters. So they were super smart researchers in biotech and that kind of thing. Every one of them wanted to know how AI works. And this is my hypothesis, is that the enterprises are very willing to invest in the technology, but they didn't do any investment or a disproportionate investment in the education of their teams, whether it's their engineers on using confidential compute, on using data pipelines, on using, LLM routing and things like that we just talked about. I think the education of people on how to solve problems in their business, in their organization, if they're a nonprofit, government, et cetera, is really as much of a gap as the wall that we're hitting with technology that we previously discussed today.
Yeah, like here's what I've observed about your training for business and enterprise users. People still think that AI is to automate writing tasks, and they don't even know the basics of, like, you write, you then give it to your co-pilot Claude and say, give me critical feedback. My audience is XYZ. Where do I improve this? People are trying to automate things, which creates AI slag instead of using it intelligently. And that's the thing that you've done so well in educating folks around how to use AI effectively.
I love having AI as a thought partner, but sometimes you almost have to say, you got to be super critical. We talked a lot today. We talked about, the technology and, the failure of these pilots. But I think it comes down to the data, and you touched on it a little bit. But if you're going to be prescriptive to an enterprise of, you're one of the 95% that has seen no discernible like ROI on their investment in AI. And you wanted to go help them. What would your prescription be today?
How to utilize your proprietary data? You use it as part of grounding with your models, and you'll hear like RAG, retrieval augmented generation, and there's other techniques. I use RAG kind of broadly for the concept of grounding. And what that means is you're taking all of your grandma's secret recipes and everybody's grandma's secret recipes and all of the culinary wizards who understand the techniques deeply, that experiential data which exists within your enterprise, and you're using it in your AI. That's how you create differentiated value with AI. It's not just using the generic foundation models. You're going to get AI slag. You need to ground it with your own proprietary data, which you have to be careful because if that gets out, well, it's in the model. Your competitors have access to that. So what we focus on is what we call confidential agents. And these confidential agents will do grounding with RAG or other techniques with your enterprise data, and nobody can see it. Not opaque, not a hyperscaler, not the model itself can. They'll process it, but they can't train on it, and you have verifiable proof of that. And that includes the metadata that's part of your interactions with it too. So number one is if you're inside of an enterprise, this totally makes sense. If you're inside of a business, this makes sense. If you're an individual, probably doesn't make sense yet. But people who are using ChatGPT are using it as a therapist. That's
Mm-hmm.
really frightening, and the way that people are interacting with these systems where they think it's their friend because they don't fundamentally understand that this is not a conscious being. They just don't. People are creating a personal emotional connection with these systems. And that's just, I'm sorry, it's just not healthy. Like I use it to understand specific approaches. Particular one I was using recently was there's this concept in cognitive behavioral therapy, and there's an acronym called RAIN, and it's about recognizing an emotion so that you can process it, so that you don't react in an emotional way. You're much more thoughtful about it. And I was trying to reconcile how that relates to Buddhist detachment. So I was having a conversation with Claude about the concept of detachment. There's a few concepts in Buddhism and how it relates to cognitive behavioral therapy. Like that's healthy, right?
Mm-hmm.
I'm getting a deeper understanding of both spiritual concepts and how they apply to living in a healthy way with modern psychological concepts. I'm not talking to it to get advice. The point I'm making here is we have to put in controls to protect people's data, their metadata around how they're interacting with this. There's the enterprise approach around confidential, and then there's the personal approach. Here's one other thing that's super important. And everybody's talking about AI observability tools, Mark, right? You and I talked a lot about AI observability tools.
Mm-hmm.
If you're using AI observability tools to protect your data, you only detect after you've leaked it.
Oh yeah.
So it's only after something's happened that you can detect it. And here's the thing, AI observability is incredibly costly. It's actually more expensive than AI inferencing. Right? This came up at Summit. You had it in your workshop. People were talking about this in your workshop. So I'm not saying you don't need AI observability, but let's be real. The problem with that is, again, your proprietary data is the only way to create a moat with AI, like a defensible competitive moat. And AI observability is going to only identify after you've leaked, and it's already too late. And furthermore, the costs are more expensive than the AI inference, which means that's not scalable. You got to protect your data. There's ways to do this through confidential AI. AI observability is only going to get you so far, and it's going to be difficult to scale just because of cost considerations. And people need to think about these systems for what they are. They're very fancy autocompletes. And yeah, I love them. They're wonderful. And there's going to be new techniques, which already are in production today, that will overcome the current limitations to continue to see exponential improvement in how these systems work. But that doesn't mean that you should think they're your friend.
I'm the history guy, and I think that and I worked for the first national international ISP and PSINet back in the mid 90s.
I
And
always
the
thought it was
first,
Cynet.
yeah, well,
I
it
thought it was
was,
like psionics because I like D&D. So I was like, oh,
yeah,
it's
no.
like the
People called it SciNet, but I think it was short for Performance Systems International was the original name, and then network. But we got everyone online, and we had the same sort of thing as everybody's online, and then they were like, well, we can't use email because we have no security for email, and then PGP became pretty good privacy, became something that a lot of companies adopted so that their emails stayed encrypted in between two different points like we use. But today that's evolved to pretty much like Signal or Telegram. Then the very, very shortly after we got, started to get people in line is when people needed secure access. And that's when VPNs started to rise. I think this is the same analogy is, we start with getting everyone to use AI, and then it surfaces the very real problem of how do we keep privacy. In those days, it was getting them on the web and then having a VPN. Today, it's we started to use AI and then realized that we need to keep our data private. So the security layer becomes confidential, which confidential computing is becoming a standard that everybody has access to and probably should consider adopting sooner rather than later.
Here's a couple of important points. You said VPN, and there's been news that just broke about Zscaler during their investor day, talking about their trillions of transaction data from logs from their customers and how they're training models on that. So they were talking about our data, and it's actually their customers' data.
Oh yeah.
So it's interesting there. Like here again, if I'm a large enterprise and Zscaler has all of my network data as part of their VPN log, I would feel very uncomfortable with them using that in building AI models or doing AI insights mining, unless they were using confidential AI. They can give me insights about my data without seeing my underlying data.
We have shared our data and our behaviors with all these SaaS companies. And most notably, we've given up all this data in the past, and the stakes were, it was pretty symmetric. We gave up our website data and we got that stuff. I don't know that it's going to be a equal exchange of value between the vendor and the AI companies.
It's not. It's asymmetric to the enterprise vendor to extract value, unless you have some kind of ability through confidential AI to guarantee that, okay, you can give me insights about my data, but you can't see my data. You can't use my data elsewhere. Mm-hmm. Otherwise, it's complete asymmetric value capture on the part of the enterprise vendor. So we should wrap it up. I mean, I guess the original question is, are LLMs dead, Mark?
I don't think anything that we're using today is dead, but I think all of it is subject to change, which is the real point there is things are changing, and but they're definitely not dead.
I completely agree. If you want to learn more about how to use AI responsibly, check out the website opaque.co. If you like the podcast, please subscribe wherever you find podcasts and leave us a review. This episode of AI Confidential was produced by Wolverton Media Solutions, Places Media, Kodiak's Media, the AIE.net, and Opaque, the leading confidential AI platform. Music is by my buddy Matt Melamuka. I'm Aaron Fulkerson.
And I'm Mark Hinkle. And we'll see you next time. Unless the evil data robots come and take us away.
Take your enterprise data and ground your AI. Oh, bug fly on my head. I got it. I don't know where that came from. Get up on the mic.
How about now?
Ooh, that sounds sexy.
Unless the evil data robots come and take us away.
To El Salvador, or wherever we disappear people in the United States now. Where do we disappear them to?
Bellingham, Washington. We feed them to the Bellingham serial killer.
The evil robots.
Robots. Is my Pennsylvania coming out?